to be solving equations with fractions. If fractions are tough for you, go back and watch the last video on multiplying and dividing fractions. So in order to solve an equation, the whole goal is to get the letter alone. So to get that g alone, we need to remove the 1/2. And remember, this is like a teeter-totter. So whatever you do to one side, you need to do to the other. So to get rid of a plus 1/2, we need to subtract 1/2. So over here on the right, all you have left is g, because 1/2 minus 1/2 is nothing. Over here on the right, 9/8 minus 1/2. Now, when you add or subtract fractions, you need a common denominator. So 9/8 is 8 as the denominator. Over here, we can get the 2 to an 8 by multiplying by 4. But what you do to the bottom, you need to do to the top. So now we have 9/8 minus 4/8. So 1/2 is the same exact thing as 4/8. So 9/8 minus 4/8 is 5/8. So if you have 9 of 8, like a pie cut into 8 pieces, you have a whole pie plus an 8. And in this one, you have half of it, 4/8. And if you take that away from each other, you're left with 5/8. I don't know if that makes sense. So if you have a pie cut into 8 pieces, 9/8 represents the whole entire pie, 8/8 plus another 1/8. So I'll color that in a different color. So 1, 2, 3, 4, 5, 6, 7, 8. That's 9/8. And if you take away 4/8, so if you take away 4/8, so you're removing 4 of the shading. So we could just literally erase them. 1, 2, 3, 4. You're left with 5/8. So 5/8 equals g. You can go ahead and rewrite that with the letter on the left if that makes more sense to you. It makes more sense to me. But you can leave it if that makes sense to you too. Here we have 3/5 k plus 5 equals 7. Now, in order to get this letter alone, the first thing you need to get rid of is 5. I kind of like to think of it as k is having a party, and its best bud is 3/5. So that's going to like stay till the bitter end. And the farther the things are away, we're undoing the order of operations. That's what you're going to undo first. So we're going to move the 5 over to its like term 7. The like terms want to be together anyways. So let's put the numbers with the numbers, moving the 5 by subtracting the 5, undoing that order of operations. So now we have 3/5 k equals 2. This became a 0. 7 minus 5 is 2. And then we need to get the k alone. So what do we multiply? I just gave you the answer. What do we do to 3/5 to get it gone, to get it to be a 1? Because 1k is the same as k. And you multiply by the reciprocal. And we did that in the last video. So over here, you also multiply by the reciprocal. Now, don't forget, 2 is the same exact thing as 2 over 1. That might be helpful. So 5/3 times 3/5, that's 15 over 15. So that's 1k. This cancels and this cancels. So we did that to get the k alone. Now 2 over 1 times 5/3, when you're multiplying fractions, you don't need common denominators. That's only for adding and subtracting. You just multiply the top with the top and the bottom with the bottom. And you reduce anything you can. So this is really 10/3. So k equals 10/3. Now, I kind of like to leave my answers in improper fractions. I find them easier to work with. But if you're taking a multiple choice test and all of the answers are mixed numbers and you need to know what that is, just make sure that you can divide that out. So how many times does 3 go into 10? 3 times. 3 times 3 is 9 with 1 remainder. So 10/3 is the same as 3 and 1/3. This always goes on top. This number always goes on the bottom. So this is the same thing as 3 and 1/3. You could also, if you have a mixed number, move it back to an improper fraction by doing 3 times 3, which is 9, plus 1, which is 10. So 10/3 and 3 1/3 are the same. If fractions are really tough for you, you can put these in a calculator and convert them to the decimal just to make sure you have the same answer. But you really want to be able to work with fractions because If you always use decimals, you'll have rounding error and you won't get the exact answers. So we're going to become one-word fractions today. Next problem, d over 3 equals negative 3 plus d. Now, there's a d on both sides. That's kind of weird. The letters want to be together. The numbers want to be together. So these are actually like terms. So we're going to move the letters together. And a d is the same thing as a 1d. So we're going to bring the d over by subtracting. So minus 1d. So we have d over 3 minus 1d equals negative 3. Did you see how I cut that d on top? Because I'm going to make it d over 1. Because 1 is the same as 1 over 1. So this is like 1d over 3 minus 1d over 1. Now, every time you're adding and subtracting fractions, you need a common denominator. So we're going to make both of these the same number. The smallest number they can get to is 3. So to get this to a 3, we're going to multiply it by 3. If you have no idea how to get them up to the same number, you can always multiply this fraction by this number and this fraction by this number. Sometimes there's a smaller number you can get it to that'll make it easier, but that will always work. Okay, so we have 1d over 3 minus 3d over 3 equaling negative 3. So 1d over 3, 1/3 d, minus 3/3 over d is negative 2d over 3. So negative 2d over 3, that's the same exact thing as negative 2/3 d equaling negative 3. So don't let where the d is confuse you. The d can either be outside or it can be on top. Both are correct. So to get the d alone, looking at either one of these, we need to undo this negative 2/3. We need to undo the divide by 3, and then we need to undo the multiply by 2. So if you were looking at it like this, you might say, okay, well, we're going to multiply by 3 first. So negative 2d equals negative 9 because the 3's cancel. And then you would divide by negative 2 to get the d alone. So d is equal to negative 9 over negative 2. Two negatives make a positive, so that's the same thing as 9/2. You don't need both the negatives. And if you divide that out, 2 goes into 9 4 times because 2 times 4 is 8 with 1 left over. So 9/2 is 4.5. Now think about what we just did, these two steps. If you thought of it like this, you could multiply by the reciprocal. So 3 over negative 2. Negative 3 alone is the same thing as negative 3 over 1. So when you multiply this over here, 3 over 3 cancels and make 1. Negative 2 over negative 2 cancel and make 1. So you have 1d, or just d, same thing, equals negative 9 over negative 2. And again, negative 9 over negative 2 is the same exact thing as positive 9 over positive 2. So these are your two solutions. Now, this decimal is not that awful, 0.5, because it terminates. So not a huge deal to write it in decimal form, but really try to keep these things in fraction form if you can, or mixed number. All right, I think you can do this one on your own. So go ahead and hit pause and try, and come back and tune in. So we're going to get all of the numbers on one side. So this 3, we're going to move over to be with the 9, and the reason we're moving it to the left is because the letter's on the right. If the letter was on the left, we would move the numbers to the right. So we just want the numbers on one side of the equal sign and the letters on the opposite side of the equal sign. So this is 6 equals 1/2 x. Now to get the 1/2 in front of the x alone, we're going to multiply by the reciprocal. So we're going to multiply this by 2. Same thing as 2 over 1. What you do to one side, you're going to do to the other. So on the right, the 2 times the 1/2 cancels. So this is just x. You could write 1x. That means the same thing. And then over here, 6 is the same as 6 over 1. So 6 times 2 is 12. 1 times 1 is 1. So x is equal to 12. I kind of really a lot like my letters on the left. So I'm going to rewrite that as x equals 12. You can always do that. You can always take whatever your final answer is and flip it. It's called the commutative property. So x equals 12. The next problem has a little tiny new twist. So 3n minus 8 over 5 equals 2. Now, when you have a fraction like this 5 goes to both. It's like 3n over 5 minus 8/5. So you can break it up like that, but I think it's easier to go back to the initial problem and think of the whole top in a parentheses grouped together. And then you can undo that divide by 5 by multiplying by 5. So if you multiply the left by 5, you can also multiply the right by 5. Or 5 over 1. It means the same exact thing. So the 5s are going to cancel, and you just have the 3n minus 8 left over on the left. And then 2 is the same thing as 2 over 1. So 2 times 5 is 10. So this is the same as this. You can undo the divide by 5 because the whole numerator is grouped together. If there was more stuff in the denominator, all of that would also be grouped together. Okay, so 3n minus 8. You want that n to be alone. This time the letter's on the left. That makes me happy. You're going to move the numbers to the right. So we're going to move the minus 8. That's very important. You need to add 8. If you're losing the negatives, if that's tricky for you, every time you see a minus, make it plus a negative. Minus is the same thing as plus a negative. So I call it slashing and dashing. You don't need a catchy word. It just helps me remember it. Don't even think of minuses as existing. Always think of them as plus and negative. So then to undo that negative, you would add. All right, so 3n equals 18. To get the n alone, you could think of this as a couple different ways. You could just divide by 3. So n is equal to 6. But you could also think of it as multiplying by the reciprocal, since that's what we've been doing. 3 is the same as 3 over 1. So multiplying by the reciprocal is multiplying by 1/3. So this is just the exact same way, thinking of it differently. The 1/3s cancel, so that's how we get just the n left on the left. 18 is the same as 18 over 1. The 18 and the 3 reduce because 18 is 6 times 3. So the 3's reduce, and that's how you get the 6 left over. 6, same as 6 over 1. If you have that, that's great too. In my brain, I would think just the plain 6 is the easiest, simplest form answer. Whatever works for you is what you should do. It's a fun problem. 6 minus x over 3 equals 2/3. So go ahead and hit pause. I think you've got this. Now, it's really exciting to see these two fractions with the same denominator, but they're not like terms. This is an x value, and this is a number value. So the first step is to move the number over. Now, that 6 is a positive 6. We're going to move it over by subtracting. So if this minus is tripping you up, I would every single time make it plus a negative. So on the left, 6 minus 6 is nothing. That's why we did that. So we have negative x over 3 equaling 6 alone. Remember, it's the same thing as 6 over 1. When you're adding and subtracting fractions, you need a common denominator. So we have 2/3 minus how many thirds is 6. So we're going to multiply both of these by 3. So this is 2/3 minus 18/3. So 2/3 minus 18/3 is negative 16/3. Remember, you can think of it as 2 of 3 pieces of a pie and then 18/3. That's 6 whole pies. So I would keep this as an improper fraction because it's going to be easier to solve. So now negative x over 3 is the same thing as negative 1x over 3. So there's a couple different methods. You're going to use what works for you. You could just multiply by 3, and then you have negative x equals negative 16. And then you could just divide by negative 1 to get rid of the negatives. I kind of think that's the easiest way, but our theme has been multiplying by the reciprocal. So if we go back up here, you can look at this as the reciprocal being negative 3 over 1. And then the 3's cancel, and the negatives cancel. 3's cancel, negatives cancel, and then you're also left with 16. So if the improper fraction makes more sense to you, I would make everything an improper fraction and always multiply by the reciprocals. 1/6 minus 2/3 x equals 1/4. So the very first step, to get the x alone, we're going to move the numbers together. Again, I would pay special attention to that minus. Don't be losing it. So I'm going to do the slash and dash. You don't have to do that. Totally optional. We're going to subtract 1/6 from both sides. So over here on the left, we have our negative 2/3 x. Now over here on the right, we have 1/4 minus 1/6. In order to subtract fractions, you need a common denominator. So you could just multiply this whole thing by 6 to get 24, and this whole thing by 4 to get 24. But these also both go up to 12 more quickly than 24. So it's going to be a little bit easier. You're going to have less to reduce at the end if you get these both up to 12. If that's hard for you, you can always just multiply this fraction by this denominator and this fraction by this denominator. But since I'm noticing 12 is the common denominator, I'm going to go ahead and multiply this by 3 because 3 times 4 is 12. And I'm going to multiply this by 2 because 2 times 6 is 12. Now, if you're doing 24, keep doing it because we're going to get the exact same answer. You need to do what works for you. So this is 3/12 minus 2/12. So 3/12 minus 2/12 is 1/12. Okay, and that makes sense. 1/4 is a bigger number than 1/6. If you think of it as a pie, 1/4 means 1/4 of the pie is shaded. 1/6 means 1/6 of the pie is shaded. If you love pie, then you're going to want 1/4 because it's a bigger piece of pie. So a bigger number minus a smaller number should just be a little bit smaller positive number. So things are looking good right here. Now to get the x alone, we're going to multiply by the reciprocal. So we're going to multiply by 3 over negative 2. If you put the negative on top, totally fine. It doesn't matter where the negative is. One negative makes the whole thing negative. What you do to the left, you do to the right. So over here on the left, the 3's cancel, the negative 2's cancel. You have an x. Over on the right, remember when you're doing fractions, it's sometimes easier to think of this as one big fraction and reduce before multiplying. 3 does go into 12. 12 is 3 times 4. So you can actually reduce the 3's. So on the top is just a 1. And on the bottom, we have 4 times negative 2, which is negative 8. So x is equal to negative 1/8. You can write it like that. You can write it like this with a negative on the bottom, or you can write it with a negative out front. I kind of like this, but you, again, need to do you, and whichever one makes the most sense to you is how you're going to write it. I just want you to know that all 3 of these are the same thing. That should not trip you up one bit. So now that you're loving these fractions, I bet you can conquer this one. 1/3 x plus 1/2 equals 2/3. Go ahead and hit pause and see what you get. So hopefully the first thing you did was subtracted 1/2 from both sides. So we have 1/3 x equals, over here, 2/3 minus 1/2. Now, in order to add or subtract fractions, you need a common denominator. We need the pie broken into the same amounts to be able to subtract that. There's no way to know if you have 2/3 minus 1/2. Those pies are not equivalent. You have to have equivalent ways that the pies are broken up to add and subtract fractions. So we're going to get both of the denominators to a 6. Now this time it works to just take this 2, multiply this by 2 over 2, and then to take this 3 on the first fraction and multiply this by 3 over 3. And that'll always work. Sometimes you can get to a smaller number, but that will always work. So over here we have 4/6, and over here 3 times 1 is 3, 2 times 3 is 6. So now 4/6 minus 3/6 is 1/6. If you have the pie broken into 6 and you have 4/6, and then you take away 3 of the 6's, so there's your 4/6 pieces, and you're taking away 3 of the 6's, you have the same denominator, you're left with 1/6. The only way you can add and subtract fractions is if they're equivalent. So 1/3 x equals 1/6. Now we're going to get the x alone. So we're going to do that multiply by the reciprocal. So we're going to multiply by 3 over 1. That is the same as multiplying by 3. So if that's what you did, great work. So now the 3's cancel, the 1's cancel. On the left we have an x. That's the same as a 1x. If you want to have the 1x, great. If you don't, great. And over here on the right, 1 over 6 times 3 over 1 is 3 over 6. So we're going to reduce that. We could have reduced it right here. If you notice that, 6 is the same thing as 3 times 2. So you're going to reduce a 3 out of both. Or you could just look here and say, oh, these are both divisible by 2. All right, so no matter which way you reduced it, you should get a 1 on top. 3 divided by, oh, they're not divisible by 2. Hold on here. They're divisible by 3 because that's what we reduced. Whew. All right, so 1 is left on top. 3 divided by 3 is 1. And then there's a 2 left on the bottom because 6 divided by 3 is 2. If you tried to do 3 divided by 2, you'd get 1.5, and that would not work. So 1/2 is your answer. 3 equals k over 2. I bet you can do this in less than a minute. So I'm hoping that you were thinking this as 1k over 2, which is the exact same thing as 1/2 k, and then you multiply by the reciprocal. So you're multiplying by 2 over 1. It's the same exact thing as multiplying just by 2, if you did that up here. And then if this is confusing you, remember 3 is the same thing as 3 over 1. So over here on the right, the 2's cancel, the 1's cancel. You have a k. Over here on the left, you have 6 over 1. 2 times 3 is 6. 1 times 1 is 1. So 6 equals k, and I love my letters on the left. So I'm going to rewrite that as k equals 6. 4/5 x equals -8. See what you can do. So hopefully you multiplied by 5/4. And I'm also hoping over on the right, you took the 8 and you put an over 1. Again, if you have methods that work, that's great. This is just one of many, many ways to do this, but you do need to make sure you're getting the same answer. So on the left, we're getting 1x, which is the same as x. On the right, so you could multiply -8 times 5 and get -40, and 1 times 4 and get 4, and reduce that to give you -10. You could also initially have seen that -8 is really 4 times 2. There needs to be a negative somewhere. It can be with the 4 or the 2. And then 4's cancel, but you need to not lose that negative. So -2 times 5 is -10, and 1 times 1 is 1. So again, I think 10 alone with the negative is an easier answer than -10 over 1, but these are the same exact thing. So the grand finale, here it is. 3/2 d equals 1/2 d minus 6. I know you can do this. This time, we need to get the letters together. There's no number alone to put like terms with this. So we're going to move the -1/2 d by adding it. So over here, the 1/2 d is gone. So 3/2 d plus 1/2 d is 4/2 d. That's kind of nice because it's already a common denominator. And then the 6 over here on the right is still a 6. So 4/2, that's actually a whole number. Hopefully you're noticing that. 4 over 2 is just 2d. If you didn't notice that, it's no big deal at all. In order to solve this, you would just multiply by 2/4. If you did notice that, you would just multiply this by 1/2, which is the same thing as dividing by 2. So again, there's a lot of different ways to think about this. I'm going to put the 6 over 1. So whichever way you did it, there's a d on the left. And then this reduces 6 over 2 is 3. Because 6 is 3 times 2. So the 2 is reduced. So you have 3 over 1. And if you did this way, 6, the 2 and the 4 reduce. So this reduces to 1/2. And then the 2 and the 6 also reduce. 3 times 2 is 6. I didn't mean to cross the 3 off. Cross the 2's off, and you also get 3 over 1. So 3 is your answer. I hope you're feeling very one with fractions and confident. There's nothing to be afraid of. Remember, you can always put this into decimals and try to check it on the calculator and see if the decimal answer works. This one is a whole number, but there will be a small error. So great job today.